All right, everybody, we're going to jump in and start with example number one. So, example number one. In a study of heart surgery, one issue was the effect of drugs called beta blockers on the pulse rate of patients during surgery. The available subjects were divided at random into two groups of 30 patients each. One group received a beta blocker, the other group received a placebo. The pulse rate of each patient at a critical point during the operation was recorded. The treatment group had a mean pulse rate of 65.2 and a standard deviation of 7.8. For the control group, the mean pulse rate was 70.3 and the standard deviation was 8.3. Then it's asking us to construct and interpret a 99% confidence interval for the difference in mean pulse rates. So before we even start, the reason that this is a two-sample mean problem is because we're dealing with two samples, and the data that we're collecting is quantitative data, which is going to result in a mean, not a proportion. So our mean is going to be the pulse rate between the beta group, which is our sample number one, and sample number two, which is going to be our placebo. Again, I recommend labeling sample one and two in order as they come in the problem. So if you look down here, this is how you should have this is how we plug in the values into that confidence interval formula that we just learned. So let me walk you through how we get all these numbers. So we first start off with our point estimate, which is going to be our sample mean from sample number one minus the sample mean from sample number two. And we subtract those to get our point estimate. Those are given to us directly in the problem. We just plug those in. Then we have our plus or minus our critical t-score. So again, you want to think about, let me move up here to show you guys this. When we're doing this, you want to think about your curve, and in the middle you have the percent of confidence. So we got 99%. So that means that we have 0.5% left in the tails. So as a decimal, it's going to be points. It's a little bit hard for me to do decimals on this. There we go. That's a decimal, 0.005. All right, so that is going to be the area that we plug into inverse t, 0.005 for the area of our tail of our confidence interval. Then for our degrees of freedom, just like explained in the formula video, you're going to take your smallest sample size and then subtract 1 and use that as your degrees of freedom, since we really have two different options because we have two different samples now. In this case, both our sample sizes are 30, so it's not going to make a difference, but a lot of times you won't have the same sample size, so you're always just going to take the lowest sample size minus 1 to get the degrees of freedom, just to get the most conservative estimate. Then after we plug that into inverse t, you're going to get your critical t-score, which is where you get 2.756. So go ahead, put that in your calculator, make sure you're getting that coming up. Remember, for critical scores, d or t, we're going to include 3 decimal places. After that, we are going to put in our new standard deviation formula that we just learned. And remember, on a confidence interval, we can call this also standard error. So that number altogether, once we calculate it out, it's going to be our standard error. The way we get these numbers is this first kind of column, if you want to think about first fraction, is your sample standard deviation from sample 1, 7.8, squared divided by the sample size, which is 30. Over here, we get 8.3 squared divided by 30, and that's the sample size and sample standard deviation from sample number 2. And then you use order of operations to calculate that out and that gives you a critical, or it's not critical, a standard error of 2.080. If you're having trouble going from all of this right here and getting it to come out right on your calculator, ask those people around you for help. I'm sure you'll be able to find somebody that's going to be able to push you in the right direction. If you're still having issues, make sure you email me and I can send you a screenshot of how exactly you should be putting it into the calculator. But in general, just make sure that you do these two different fractions first, add them together, then take the square root. All right, so now we just essentially use order of operations to finish calculating this out. Our standard error, like I said, is 2.080. When we subtract our two means, we get negative 5.1. And since we had the beta blocker first minus the placebo, that's essentially saying that on average, the beta blocker had a pulse rate that was 5.1 lower than the placebo. Or you think about inverse of that, the placebo had a pulse rate that was 5.1 higher than the beta blockers. So then we go through and calculate this out. We get negative 5.1 plus or minus, and take a second and think if you can remember what this number is called right here. Once we calculate all of that, what the number to the right of the plus or minus sign is called. Did you get it? You should have had margin of error. And that's the important part of our confidence interval that we calculate. So when we add and subtract that from the negative 5.1, we get negative 10.83 to 0.63, which is our confidence interval. So let's go ahead and see how we interpret this. So we are 99% confident that the interval from negative 10.83 to 0.63 captures the true difference in the mean pulse rate of patients receiving a beta blocker during surgery and those who take a placebo. All right. Excuse me. So again, we want to make sure that we have a concise, clear, contextual interpretation. So in that response, one sentence, but it's had all the information that we need, especially including what it's talking about in context. If you just said we are 99% confident that the interval, that the true mean difference is between negative 10.83 and 0.63, you would only get partial credit for that because you're not including context. You want to make sure you're including context into your interpretations.